So, good morning, everyone, and welcome to this brand new lecture on a brand new day. And this is a brand new topic as well. And the good thing is that we have gone ahead of the JEE students. We have gone ahead with them, and we are starting with motion in 2D. And I hope that we always remain ahead with those students. Motion in two dimension. Now, what do you understand by motion in two dimension? Up till now, what was happening was the motion was either happening on the x-axis or the motion was only happening on the y-axis. Yes or no? Do we understand this? From now onwards, what is going to happen is that motion is going to happen on both the axes together. So the particle would be moving along x-axis, the particle would be moving along y-axis. In short, the particle will be moving in a plane. So motion in 2D is better known as motion in a plane. Do we understand this? Motion in a plane. Plane means not aeroplane. Plane means a two-dimensional surface. Two-dimensional surface is what you are writing on your books. Your notebook is a two-dimensional subject, two-dimensional object. Your table is a two-dimensional object. You are writing on it. So basically, a motion that takes place in two dimensions, where only two dimensions, x or y, x or z, or y or z changes, is known as motion in two dimension. Have we done motion in two dimension before? Yes or no? We have done motion in two dimension before. Yes, because whenever we did motion in 1D, we had done the definitions. All those definitions still remain true. Nothing changes. So without what? Without wasting any more time, let us straight away move into equations of motion. And remember, in most of the cases, this equations of motion for 2D will be coming when the acceleration is constant. When the acceleration is constant acceleration. Can you tell me what is the first equation of motion when the acceleration is constant? The first equation is simply v is equal to u plus at. So you understand that? Understand what? Nothing has changed. Previously also the same equation was there. What will be the second equation? The second equation is displacement is equal to ut, I'm writing in vector, plus half at square. Do we understand this? Yes or no? No, yes. The third equation that I'm going to write is v dot v. As I told you, this equation looks a lot different than it is actually is u dot u plus 2 times a dot delta r. Remember, all the questions of motion in 1D, we solve by these three equations, either 1 or 2 or 3. Sometimes 1 gives you the answer fast, sometimes number 2, sometimes number 3. We have seen that, yes or no? Then the next one is the displacement in the nth second, and we got the answer as u plus a by 2 into 2n minus 1. We remember all these equations, yes or no? Now, the problem, not the problem, the only thing that is different in motion in 2D, it is not different, it is actually same, that we may not use these vector equations. Instead of using vector equations, we may use equations along x-axis or equation along y-axis. But let us first solve a problem where we have a general motion and let us see whether we can solve that problem or not. Are we ready? So the first problem that comes to you is question number 1. A particle has velocity v is equal to 3I minus 2j and acceleration equal to 2I plus 4j. Find the velocity and displacement after t is equal to 2 seconds. Do we understand the question? The first velocity that is given to you is definitely your initial velocity. The second is your acceleration. As you can see, acceleration is constant, my dear friends. They're asking you to find out the velocity and the displacement after 2 seconds. I'll also give you 2 seconds. No, I'll give you 2 minutes to solve this. Get the answer and stay happy. Happiness is what we are searching for. And we'll only get happiness when we are selected. That is our ultimate aim. I'll give you 2 minutes. Yes, bacha. Are you able to do this or shall I do it? Do you want time or shall I do it? No answers? No answer is always a very bad thing to do. Do you want time? Are you trying or shall I do it? Okay, I'll give you time. So I think you have tried it enough. Let us discuss the answer. How do I find the final velocity? Initial velocity is given to me. Acceleration is given to me. How do I find the final velocity? I apply the equation. I don't know what you were doing for so long. V is equal to u plus at. The value of u is 3I minus 2j. I write it here. Plus acceleration is 2I plus 4j multiplied by time is given as 2 seconds. I just put the values 3I minus 2j plus 4I plus 8j. And now add them 7I minus 6j. That is the answer for my velocity after 2 seconds. It is so difficult to get better. Multiply, divide, even not division. Just had to multiply and add. It is so difficult, beta. Can you tell me what was the doubt, beta? So that I understand what you were thinking. You had no doubt, you have no doubts, but you still could not do this. Tell me what was troubling you, please. Oops, I think I have not shared the screen. Okay, v is equal to u plus at. Just had to add. Now tell me what you were not able to do. U is given as this. A is given as this. T is given as this. What was the doubt, beta? Please tell me so that I understand what was wrong. Okay, there was no doubt. It seems you could not do this. How do I find out the displacement? I find out the displacement like this. I put the formula ut plus half at square. I put the values of u. U is 3I minus 2j. I multiply it by time, 2 seconds, plus half. Acceleration is 2I plus 4j multiplied by t square is 2 square. I just now multiply it 6I minus 4j, and from this 2 I can cancel 1 2, so plus 4I plus 8j. I will now add I with I and j with j, so the answer that I will get is 10I plus 4j. That is my displacement, my dear friends. It was so simple. Just today only I was telling this engineering student that you are so good. But if you don't tell me what you don't understand, I'm only hitting arrows in the dark. If I don't understand what you don't understand, I will not be able to help you out. So if you don't want to tell me what you don't understand, well, I will just hit arrows in the dark, and I hope that one of those arrows hit the target. So please note this down. Please let me know once you are done so that I can move ahead.
Completed, sir.
Okay, good that you have completed it. Now, that is one way of doing the question, that you straight away do it with your vectors. We might not employ this technique because you might not get a question like this in the examination hall, but you must be prepared. Or the other way of doing this same question would have been that you make two equations, one equation along x-axis and the other equation along y-axis. You make these two equations, one along x-axis, one along y-axis, and then you write the two equation. Now, how will you write equation along x-axis? Vx is equal to ux plus ax into t. The second equation becomes displacement along x. Let me call it as x. X is equal to ux into t plus half ax into t square. The third equation I can write it as vx square is equal to ux square plus 2 times ax multiplied by x. What I have done here is I have written velocity as vx, that means velocity along x. Ux means initial velocity along x. Ax means acceleration along x. Do we understand this? Fourth equation, the x coordinate in the nth second can be written as ux plus ax by 2 into 2n minus 1. I hope we understand this, yes or no? But remember, whenever we are making this equation, we are making them with a sign convention, and the sign convention is whatever goes this side is positive and whatever comes this side is negative. Remember, do not forget this sign convention. Do we understand this? Similarly, we can make equation on y-axis. What will be the first equation on the y-axis? Can anyone tell me? What is the first equation of y-axis?
Vy is equals to uy plus ayt.
Well done. Vy is equal to uy plus ay times t. What about the second equation, bacha?
Y is equals to uyt plus half ayt square.
Uyt plus half ayt square. Very good. What about the third equation, beta?
V square y is equals to u square y plus 2ay into y.
V square y is equal to u square y plus 2 times ay multiplied by y. Okay. What about the fourth equation here, beta?
Yn is equals to uy plus ay by 2
Uy plus
ay by 2
ay by 2.
into 2n minus 1.
So here we come. These are the equations that you might have to use when the questions come. I'll give you 2 minutes to note them down, please. Please let me know once you are done. Are we done, bacha? Yes or no? No, yes. Okay. Now, whenever we are talking about motion in 2 dimension, the first thing that comes to our mind as soon as we think about motion in 2 dimension or motion in a plane, the only type of motion, the first type of motion that comes to our mind is which one? You must have heard about this name. The first type of motion that comes to our mind as soon as we talk about motion in 2D is which motion, bacha?
Projectile motion.
Yeah, see, I always tell you that NEET students are way ahead of the JEE ones. Projectile motion is the first type of motion that comes to our mind when we think about this motion in 2D. Now my question is, have we done this projectile motion before? Where? Where have we done this if we have done this? Remember, any motion which take now when we talk about projectile motion, there are certain things that you must remember. So what are the things that you must remember about projectile motion? Any motion that takes place under the effect of gravity only. Remember, the only force that must be acting should be gravity only. Do we understand this? All other forces except gravity are neglected. Air resistance, everything is neglected. All other forces are neglected. G, what do you mean by G? What do you mean by G?
Acceleration due to gravity.
It's always taken as constant and is directed vertically downwards. It's actually not directed vertically downwards, but we take it like this. Do we understand this? There are other points as well which may not be of so importance for NEET. This motion is taking place very close to the surface of Earth. Should not be very high. And that is it. So any motion that takes place under gravity where G is assumed to be constant, it is always assumed to be vertically downwards. All other forces are neglected except gravity. That motion is known as what, my dear friends? That motion is known as
Projectile motion.
projectile motion. Having said that, I can now classify this projectile motion in many categories, 2 or 3 categories that we are going to do. Right? Wrong color. Category number 1, number 2, number 3. What could be those 3 types of projectile motion that we are going to study? The first one I can call it as vertical projectile. The second one I can call it as oblique projectile. And the third one I will call it as horizontal projectile. Vertical oblique, and horizontal. These are the three different ways in which I can study the projectile motion. Out of this, one of this we have already studied. Which one? The one we have already studied is vertical projectile motion. Vertical projectile motion was nothing but motion in 1D under gravity. Do we understand this? What was happening here? You were you were standing on ground. A ball was thrown up with an initial velocity u. It was getting to certain height h. It was stopping there at the highest point. Velocity was 0. And then it was coming back. We have studied this motion under gravity. Yes or no? That is also an example of projectile motion. This is also projectile motion. We sometimes forget that motion under gravity, but this is projectile motion in 1D. So instead of calling it as vertical projectile motion, I can also call it projectile motion in 1D. Do we understand this, my dear friends? Vertical projectile motion can also be called as projectile motion in 1D. Dum, ball thrown up, coming down. From the top of a tower, ball drop, coming down. From the top of a tower, ball thrown up, coming down. That is the example of a vertical projectile motion. Now then what do you mean by oblique projectile motion? In vertical projectile motion, I had this ball. I threw it vertically upwards. It came vertically downwards. This was motion in a straight line. It was projectile motion, but motion in a straight line. The next is oblique projectile motion, which is what we are going to study now. Oblique projectile motion. In this, what is going to happen? In this projectile motion, what is going to happen? It is known as oblique. Can you tell me what is going to happen? In the first motion, ball was thrown directly up. It came directly down. What is going to happen in this case? You know it. I know it. That you know it. What is going to happen in this case? Yes, bacha. In first case, ball was thrown up, dum, and it came down, dum. What is going to happen here now? What this? Tell me what is this? Instead of ball being thrown up, the ball will be thrown at an angle with the horizontal with an initial velocity u and angle theta. This u is known as the initial velocity, and this theta is sometimes also known as the angle of projection. Yes or no? And then it does not go vertically up and vertically down. It goes vertically up and vertically down, but it also goes forward. It follows a path. This path may be known as the trajectory of this projectile motion. And we will see that this path or this trajectory of this projectile motion will come as a parabola. Parabola is a type of a curve, just like your circles or straight line. Straight line is a straight line, circle is a curve. Parabola is also a curve. Ellipse, parabola, hyperbola, cone, all these are curves. Do we understand this? Yes or no? Now it goes up. It goes up and it reaches certain highest point. Yes or no? This height is known as h max. This height which it reaches is known as h max. Maximum height. It covers some distance on the horizontal ground that is known as range. Any one of us knows this, yes or no? It spends some time in air. It spends some time in air. That time is known as t, which is nothing but time of flight. I have used this term time of flight before also. Yes or no? No, yes. Eh? Ah, time of flight. Okay. Now to understand this motion, what we can do is, this is motion in 2 dimension. We can break this motion into 2 parts. Yes or no? One motion is along where? To understand 2 dimension motion or motion in a plane, we can break the motion into 2 parts. What are the 2 parts in which we are going to break the motion? Motion along? Motion along?
X-axis and Y-axis.
Motion along x-axis and y-axis. That is correct. So basically what I'm going to do, break it. So I resolve u in 2 components. One component will be known as ux, which is along x-axis. The other component is known as uy, which is along y-axis. Everyone understands this, yes or no? This ux will be equal to u cos theta, and this uy will be equal to
U
u.
sin theta.
Instead of calling it as u cos theta, I will call it plus u and plus u sin theta, because I have to take a sign convention. This is positive and this is positive. So uy is plus u sin theta and ux is plus u cos theta. Do we understand this?
Yes, sir.
Let me call this point. I hope everyone is drawing. Let me call this point as O. Let me call this point as A. Let me call this point as B. O is the point of projection. A is the highest point and B is the point where it falls back. Yes or no? No, yes. Time taken to go from O to A. You can call it time
Time
taken.
of ascent.
Yes, well done. Time of ascent or time taken to go up. TA, ascent. Then, what is this? Dung, 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 dung.
Time of descent.
Well done. Time taken to go down. Or you can call it TD or time of descent. Well done. What is the relation, my dear friends, between TA and TD or T up and T down? What is the relation between time of ascent and time of descent? Time taken to go up, time taken to come down. So these are some of the important points that we are going to write. So let us start with some important points. Do we understand this? You have drawn this diagram, everyone? Let us write some important points referring to the diagram. The first important point, let us write the equation along x and y axis so that if we ever require them, we have those equation x axis and y axis. What are the things that we know about x axis and y axis? What is the initial velocity along x axis? It will be plus u cos theta. What is the acceleration along x-axis? It is 0. Do we understand this? Acceleration along x-axis is 0. Do we understand this? Yes or no? Acceleration along x-axis is 0. Now if I write the equation Vx is equal to Ux plus Ax into T. Ax is 0. So you will get this very good equation that Vx, the final velocity along x, will always be same as the initial velocity along x. Do we understand this? That means velocity along x never changes. It always remains same. This is point number 1. Velocity along x never changes. It always remains same. Why does it remain same? Because acceleration along x-axis is 0. Do we understand this? Then if I have to write out the third equation, x will be equal to ux into t plus half ax into t square. This part goes away. So I will have this equation, the third equation that I must remember for x, the distance along x-axis will be equal to ux into t. Do we understand this? So what are the points we have learned about x-axis? Acceleration along x is 0. So velocity along x never changes. Yes or no? No, yes. Let us think. Let us now go on. What do we know about y-axis? What is the initial velocity along y-axis?
Sin theta
Plus
plus u sin
u
theta.
sin theta. What is the acceleration along y-axis? It is equal to minus g. Why it is minus g? Because it is downwards. Why it is plus u? Because it is upwards. So now if I write the equation for y-axis, I will get the first equation Vy is equal to uy plus ay into t. Let me just write the values here so that I don't. Vy will be equal to plus u sin theta minus gt. Do we understand how I have got this equation? I have just put the values from the equation and I have got this equation. That means this is again an important point. Velocity along y keeps on changing because there is acceleration along y. So velocity along y keeps on changing. Do we understand this? What is the second equation that I can make? Y is equal to displacement along y-axis will be equal to plus u sin theta into t minus half gt square. This is the equation that I can make along y-axis. Do we understand this? Yes or no? No, yes. Anyone understands this? Then the third equation I can make is Vy square will be equal to Uy square plus, oh, let me not write it as plus, let me put the values, that would be better. So this will be equal to U sin theta square plus 2 times acceleration is minus g multiplied by y. Do you understand how I written this equation? So these are the equations. From these equations, if I number them, equation number 1, equation number 2, equation number 3 along x-axis, equation number 4, equation number 5, and equation number 6. These are the three equations along y-axis. I can solve any question that comes in this particular case. Do we understand this? Yes or no? I'll give you 2 minutes to note this down, bacha. Please let me know once you are done, beta.
Completed, sir.
Okay, since we have completed this, what we will do is we will write important points about what we have seen point wise. So point number 1, write important points. Important point number 1, let us first summarize the point of x-axis. Important point number 1, acceleration along x is always 0. Do we understand this? Velocity along x, that is Vx, is always equal to Ux. That will be always equal to plus u cos theta. Do we understand this? Yes or no? Point number 3, displacement along x will be always equal to u cos theta multiplied by t. Do we understand this? Huh? Acceleration along y is always equal to minus g. Velocity along y keeps on changing. It first, I'm throwing the projectile up. What happens to the vertical velocity? We call it vertical velocity. What happens to the vertical velocity? Does it remain same? Does it increase? Does it decrease? Or first it increases and then it decreases? First it decreases, then it increases. What happens about the vertical velocity Vy? Tell me, fatafat. This is no physics. This is common sense. What happens to the vertical velocity? Does it change? We know that it changes. Does it increase? Does it decrease? What happens? Tell me. Huh?
Increases.
Vertical velocity increases. Okay. Anyone else with a different idea?
No idea, sir.
No idea is always better. If you don't have any idea, it's better to say no idea. So, as you can see, while it is going up, when I throw this stone up, what happens to the velocity? Tell me. You know that. You must be having idea about that, right? When I throw this stone up, what happens to the velocity of this stone? Tell me. It remains same? It increases? It decreases? Yes. When you throw something up, what happens to the velocity? Does it increase? Does it decrease?
Decreases.
So what happens with this? It also decreases. It decreases, then it becomes 0, then it increases in the downward direction. Is it difficult to understand? Is it difficult to understand, beta? Have you understood this? Okay. At the highest point, what happens at the highest point? At the highest point, and we had said, we have called that point as A. At the highest point, velocity Vx will be equal to plus u cos theta, but your Vy, velocity ka y component, will be equal to 0. Do we understand this? Yes or no? No, yes. Okay. Time taken to go up or time of ascent is equal to time taken to come down. And this is equal to total time divided by 2. We have also seen this previously in your motion under gravity. Yes or no? Okay. Now, let us see what happened at point B. At point B, which is point B? This is the point B. I hope you have marked it. Yes or no? Now, at point B, you have marked point B. Let me extend this line. At point B, the ball is actually falling back. Yes or no? The projectile is falling back. It falls back with some velocity. It falls back with some velocity. Let me call that velocity as V. Now this velocity V can be resolved into two components. One will be Vx and one would be Vy. It was thrown with certain velocity. It falls back with certain velocity. I'm calling that velocity as V. Do we understand this, everyone? What can you say about Vx? What will be the value of Vx? Think patiently. Answer it. What is the value of Vx, beta?
Plus u cos theta.
Well done. See, if you just answer everything patiently, plus u cos theta. What about Vy?
0.
Think again. Just jump on to answers very quickly. If I
Plus
throw,
u sin theta.
huh?
Plus u sin theta.
Plus means is it going up?
Minus u sin theta.
Well done. So you see, you take a deep breath, you think, and then you land up with the correct answer. It is minus u sin theta. Do we understand this? What about this angle? How much will be this angle? The angle at which it falls. The angle it was thrown up was theta. What is the angle which it falls? Take a deep breath. Trust me, take a deep breath. And then you will be able to give me answer in a flash. And the answer is, huh? Take a deep breath. Like this. Yes, bacha. What is the answer is? What is the answer? And this angle is also the same angle, theta beta.
45.
Okay, same angle theta. I don't know from where you create all these fictitious angle 45, 60, 90. We're talking about general case beta. 45 angle can be the angle if both ux and uy are same. but that will depend on which velocity I am throwing and which velocity and what is the angle of throwing. Okay, do we understand this? Yes or no? No, yes. So these are the important points. Time of flight we have done. So at point B, we will write those points and we will call it a day today. Call it a day today. At point B, let us write velocity ka x component will be plus u cos theta. Velocity ka y component will be minus u sin theta. So basically it is falling with the same speed, but it is falling with a different velocity. Why same speed? Because magnitude is same. Why different velocity? Because direction is different. Do we understand it? It was thrown like this, but it is falling like this. It was thrown like this, it is falling like this. Do we understand this? With this, we come to an end for this first lecture, which was very eventful. We have seen some important things about motion in 2D. We have seen that motion in 2D is not anything different, but is the same thing that we have done, and we are going to study motion under constant acceleration. We have seen that motion under gravity is known as projectile motion, and we have seen different type of projectile motion. The first projectile motion we have already seen in motion in 1D, that was vertical projectile, dung 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 dung. Now this is pung 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 pung. It is going like this. It is going at an angle, so it is not only moving up and down. It is also moving in the horizontal direction. So what we have done, we have broken it into two parts. One is this motion, duck 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 duck, and one is this motion, duck 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 duck. And both the motions are independent. So we are going to study them separately as x-axis and y-axis. We'll continue with this lecture in the next class. Take care. Have a nice day. God bless you all. If you have any doubts, I'm always there.